Okay, we're going to take a look at our nav plotting questions here on exercise 1. These are going to involve the wind face of the E6B flight computer, and one of them is going to involve both sides. We're going to be doing a true airspeed conversion in one of these problems as well. Let's take a look at the first one. We have a track, and that's in parentheses T for true, so a true track of 045 that we want to make good. Our wind velocity is 270 at 30 knots, and the temperature, which is not a factor in this problem, is minus 15. So that's the way that is read. So the wind is coming from 270, 30 knots, temperature minus 15. Our true airspeed is 100 knots. So what true heading do we need to fly to make a track of 045 good, and what will our ground speed be? Okay, the first step in this problem is to put our wind vector and velocity into the wind side face of the E6B. So the first thing I'm going to do is set my wind vector, which is 270, underneath the true index. Just for reference purposes, I went ahead and slid the E6B down to 100. I have to plot up 30 knots. So as you can see here, we're going 10, 20, 30 knots, and using a felt, I put a mark at that point that represents 30 knots, and also just to help me see the wind vector when I'm plotting the wind correction angle and also the ground speed. I've put a line with an arrow pointing to that dot. So the next thing we need to do is to put our track that we want to make good into the wind face. Okay, with a track of 045 put into our true index, we can now go ahead and plot our ground speed and wind correction angle. So what I'm going to do is I'm going to slide this so the dot that I place representing our wind vector, wind velocity, is going to be on our true airspeed. In this case, our true airspeed is 100 knots. So you can see where that dot matches our true airspeed. And if I read underneath the grommet, that's going to provide me ground speed. So underneath the grommet, I'm going to call this 119 knots is what my ground speed is, because I have a tailwind, and my wind correction angle is 10, 12 degrees. So that's left 12 degrees, and that is going to result in a true heading that we're going to fly of 033. So 045, which was our track, minus the wind correction angle, the left wind correction angle of 12, gives us a true heading of 033 and a ground speed of 119 knots. Okay, problem number 2 is the same type of problem. Different track. Track true is 240. Wind velocity is 040 at 20 with a temperature of minus 10. Our true airspeed is 90 knots. Given those parameters, what is our true heading and what is our ground speed? Okay, putting 040, which is our wind vector, into the true index, went ahead and marked up 10, 20 from a reference point. And again, you don't need to use 100 for that reference point. It does make it a little bit easier, again, if we slide this down, to go ahead and just very quickly look up if we need to put 20 knots in, to go ahead and put that mark there. So the next step is going to be, after that, to go ahead and put our track in and do our wind correction angle and ground speed calculation. Okay, putting our track of 240 under the true index. Go ahead and we've slid the E6B, so our mark is on our true airspeed, which is 90 knots, showing a right wind correction angle of 4 degrees, and looking underneath our grommet, reading our our ground speed. That's ground speed. It's 109 knots. So our final answer is, given a track that we want to make good of 240, a right wind correction angle of 4 degrees, our true heading is going to be 244. Given a true airspeed of 90 knots, our ground speed is going to be 109 knots. Okay, the next problem is going to involve an additional step, because as you can see, we're not given a true airspeed. We need a true airspeed to do our wind phase calculation. We're giving it an indicated airspeed. We have an altitude, a pressure altitude, and we have a temperature. So the step 1 in this problem is going to be using the other side of our E6B and calculating a true airspeed given a pressure altitude of 8,000 feet an indicated airspeed of 100 knots, and a temperature of -25. Okay, step 1, using this window right here, we have set in -25 degrees and 8,000 feet of pressure altitude. Now, once that's been set in, we can go look for our indicated airspeed of 100 knots, or what represents 100 knots on the inside scale, and reading opposite of that, we have 108 knots for a true airspeed. So when we flip the flight computer over and use the wind face, we'll be using 108 knots true. So again, step 1 was the conversion from indicated to true, and that answer is 108 knots. Okay, so continuing on with phase 2 of this problem, we've set the wind velocity, which is 340, under the true index, and I've made a mark representing 15 knots on the wind face of the flight computer. Alright, and to finish this problem off, we put the track of 135 in our true index, and in this problem they're only asking for a true airspeed solution. I'm sorry, a ground speed solution. So using our calculated true airspeed based on altitude and temperature that we've just previously done of 108 knots, I've slid the E6B so my dot is on the 108 knot mark. Reading underneath the grommet, my ground speed is 120 knots. So the answer for number 3 is a ground speed of 120 knots. And if you're curious, it looks like we have a wind correction angle of between 6 and 7 degrees to the left, but that's not required. So the final answer is ground speed of 120 knots given the inputs of the problem. And the last problem in the nav and plotting questions is back to the original format. Given a true track of 330, a wind velocity of 020 at 25, -15 temperature. And again, for these problems, since we are not calculating true airspeed, temperature does not come into play, but it's still given in the wind report. We need a true heading and a ground speed based on a true airspeed of 125 knots. So the very first thing we'll do is put the winds in the flight computer. Step is to put our wind vector in 020 into the true index, and I went ahead and marked up 25, put my felt mark, and went ahead and drew a small arrow. So we'll go finish off the problem once we spin our track into the E6B. Okay, putting our track that we want to make good into the true index. I've slid the E6B so our mark is on 125 knots. Reading that, in this case, the ground speed 107 to 108. It's the angle. The angle this camera's pointed distorts that a bit, and a wind correction angle of +9. So our final answer is a true heading of 339 and a ground speed of 107, 108, depending on how tight your E6B is put together and any discrepancies in your viewing angle when you're actually putting the mark down. So the precise answer is a true heading of 339 and a ground speed of 107.